Hi everyone, and welcome to an overview of Chapter 11. We're talking about circles in this overview. Now that tends to be a big topic on the SAT, so if you have the time, I would definitely suggest looking in more depth into this chapter. I've just picked a few highlights from 3 of the different lessons in this chapter. So let's take a look at what we're talking about. You're probably already familiar with the radius of a circle. It goes from the center of the circle to the edge of the circle. And you probably have already heard the word diameter as well, which connects 2 points on the circle and it goes through the center of the circle. Now, other lines and segments that intersect the circle are known as chords, which connects 2 points on the circle, but it is not a line, it's a segment. Secants, which are lines that intersect the circle in 2 points, and tangents, which is a line that touches the circle at exactly 1 point. That point is known as the point of tangency, and tangents are actually perpendicular to any diameter or radius for the circle. Okay, so we're going to practice with using these new terms. And one other side note for you is that this diameter is also a chord because it does fit the definition. It's a segment that has 2 endpoints that lie on the circle. So let's take a look at an example of labeling with these term words. In example 1, we're asked to identify each line or segment that intersects circle A. So we need to find a chord, the tangent, the radii, the secant, and the diameter. So we have to name as many segments on the circle that apply. Okay, so see if you can do that and then press play to see what I got. So there are actually 2 chords, chord EF, which just goes from this point to that point. So although it does have arrows on the ends, if I call it segment EF, then that would make it into a chord. Then there's BC. So line segment BC is a chord. For a tangent line, line L is a tangent line. Now, because this is a cursive L, I can't call this line CL because C is naming a point and L is referring to the entire line. Line L is the tangent because it touches the circle just at this point, and that is the only place that it touches. Next, we have the radii. There are 2 of them, AC and AB, because they go from the center of the circle to the edge. There is a secant line, line EF, right here. And then there is a diameter, and that's segment BC, because that goes all the way across the middle of the circle. So it's time for a check it out question. In check it out number 1, you're going to use the picture to label each segment or line with the proper term. And what I've done is instead of using what the book gives, which is just label everything you can, I've asked you to label certain segments or lines. So see if you can go through and figure out which term would apply to each of these, and then press play to see the next part of our lesson. The next thing we're going to talk about is a theorem. Now this theorem doesn't have a name to it, so I wrote the number. Please remember that those numbers do not mean anything other than what chapter we're in, what lesson we're in, and where it appears in the lesson. So these numbers do not mean anything to anyone outside of our class. So please do not use these numbers to refer to the theorems. If you need to reference this theorem, you would just write the fact. And this fact says, if 2 segments are tangent to a circle from an external point, then the segments are congruent. Okay, so here's point C out here. And CA is tangent to the circle, and CB is also tangent to the circle. Now, what you'll notice is that this will make congruent triangles because we know that this segment is congruent to itself. We know the radii are congruent to each other, and we know we have a 90-degree angle here. Okay, so that makes hypotenuse leg congruence in both of these triangles, and that's why this is true. But what you can remember is if you see what looks like a party hat, okay, imagine this is a person's head and this is the hat, then you know that this side is equal to that side, and that's really what it's saying. Okay, let's look at an example of this. In example 2, they tell you that DE and DF are tangent to circle C. They want you to find the length of DF. Okay, so we're going to use that theorem that we just talked about. Remember, if I have two tangents that meet at a point, think about what's going to be true about their lengths. So see if you can solve this one, and then press play to see if your answer is correct. So what I remembered is that these two segments are congruent. So all I had to do was make an equation saying that 5y minus 28 equals 3y. Now to solve this, what I did is I subtracted 5y on both sides. Then I divided by -2, and I found out that y is 14. Now it's very tempting to stop there, but they wanted the length of DF. So I took my 14 and put it into the expression here. I did 3 times 14, and I found out that DF is 42. So it's time for another check it out question. In check it out number 2, they tell you that segments RS and RT are tangent to the circle, and they want you to find the length of RS. Some of these equations can get a little hard, so just do your best with them. I promise that on your quiz or your test, it won't be this hard. Okay, so see if you can do that, and then press play to see the next part of our lesson. In 11.2, we talk about arcs and chords. Now, the central angle made in our circle is an angle that has a vertex at the center of the circle. So it kind of looks like a slice of pie, okay? This angle creates a slice out of our pie, okay? Now, it creates what we call an arc. So this part here, this AB, is what we call a minor arc, okay? Now, we can also have a major arc, which is a big arc. And when we name a major arc, we name 3 letters. So ACB goes the other way around the circle, and that's a major arc. It's a bigger arc. The minor arcs are smaller. They tend to have acute or slightly obtuse angles, but once it gets past 180 degrees, we call it a major arc. But basically, it's just a portion of a circle that it consists of these 2 endpoints and the part of the circle that's between them. Now, there is a verb that we use to describe an arc, what an arc does. It subtends an angle. It's a very special verb that just means that this arc goes over this angle. Okay, now the last fact about an arc is that the measure of the arc is equal to the measure of the angle that it subtends. So if this angle was 45 degrees, this arc would be 45 degrees. We measure them in degrees. Okay, so we're going to take a look at an example where we need to find arc lengths. So let's take a look at what's going on in example 3. In example 3, they've asked us to find different arc measures. Now this was the closest I could get to that arc symbol. It's not exactly right. You saw it in the previous slide, but we want to find the measure of these 3 different arcs. So the measure of arc CDE, okay? CDE. So think about how we could figure out what that is. Please notice that BE is a diameter and AD is also a diameter. So think about how I could figure out CDE and then press play to see if you're right. So what I figured out was that angle CFD is 90 degrees. So CD is 90 degrees right here. And because these are lines that cross, I have vertical angles. So if this is 18 degrees, then this is also 18 degrees. So I know that DE is 18 degrees. So all I had to do was 90 plus 18 to get my arc length of 108 degrees. So now that you've kind of seen how this works, try and do B and C and then press play to see if you get them right. So for part B, they wanted the measure of arc BC, which is right here. Okay, and what I remembered is that radius FC is perpendicular to diameter AD. So if this is 90 degrees, then this part over here is also 90 degrees. And this is 18 degrees. So I just have to do 90 minus this 18 to get 72 degrees for BC. Then for AE, which happens to be here, AE, okay, I know that AD is a diameter. And a full circle has 360 degrees. So this half of the circle has 180 degrees. And if this is 18 degrees, then this is 18 degrees. And I can do 180 minus 18 to get 172. So arc AE is 172 degrees. It's time for another check it out question. In check it out number 3, you need to find the measure of these two arcs. So the first one is JKL. So you need this total measure here. And the second one is LJN. So it's this big arc going all the way around this way. So see if you can find those measures and put them on your response document. And then don't forget to watch the next video in this lesson.